So my name is Marc Aubreville, to be precise. I'm a professor at Technische Hochschule Ingolstadt. That's the University of Applied Sciences in Ingolstadt in Bavaria, Germany.
Jonathan Ganz, I'm a PhD student here at THI, and also I have a co-supervisor at FAU in Erlangen. Yeah, well, it was about the automatic assessment of agnors from histopathology images. So agnors are a part of inside nuclei of cells, and the number of agnors is correlated to cell proliferation. So if we have more agnors, we have a quicker proliferation, and proliferation speed is always of interest in tumor diagnosis. We want to measure cell proliferation as precisely and as closely to the biologic behavior as possible. And the agnor is one way to measure it quite precisely. There are other means like counting mitotic figures and stuff like that. And here, agnor score adds a little bit of explainability.
You could also say that, so, I mean, typically we want to know, like, okay, so how many cells are dividing? That's the mitotic figures, right?
Yeah.
But with agnor, we also find out, like, how fast are they actually dividing? So that's the add to the science.
Okay.
First of all, we have very nice collaborators in veterinary pathology, which gave us some interesting probes with which we were able to work. And also we worked with supervised learning here, and it's quite a lot of effort to establish a data set like which we were working on. I think there were roughly 23,000 annotated cells inside the data set, which is quite a lot. And also agnor isn't too easy to establish. So there are other means like Ki67 or counting agnors or stuff like that, which I think are a little bit easier.
Counting mitosis.
Mitosis.
Yeah.
Which are easier for laboratories and also for pathologists to do.
So, I mean, as usual, you always have to have like a crazy collaborator that is willing to spend the effort, right? So that's at the first steps of every good research is people with curiosity. And big shout out to Christoph Bertram, who is our collaborator here. He did an excellent job also like in pushing us towards saying, hey, this is an important topic. We need to work on that together.
I think what's kind of special is that we didn't only focus on the algorithmic part, but also on how good humans are at the task. So the problem is that by now, agnors are almost only counted under the light microscope, and so there is not much information about how good humans are in doing that task in digital pathology. So since we wanted to compare our algorithmically results to human raters, we first had to conduct some kind of human rater experiment, where again, we needed some crazy pathologists with which we could do our little study. And well, they were quite handy. It was really quick job that we did there. And that's kind of interesting, because I don't think that you have that kind of stuff very often, where you can compare a task which you now try to solve algorithmically to human raters. I think that was
maybe I think, I mean, one of the things that also some of the reviewers that we met there in person told us that they liked about the paper was that it established a new task. So I mean, most or much of machine learning research is working on established tasks where you have a good baseline, where you have like a solid understanding of the data already, and here to go ahead and say, okay, you know, we have a new task which is also very important, which has for some reason not yet been established, and one of the reasons actually being, well, there is no prior like baseline, right? So there is no data available at the moment. It's also not a routine task because it's so tedious to do. So it has not been established in like the normal workflow of a pathologist because it's so tedious to do. Although it's known that this is really highly indicative of outcome, especially for the domain where we work on, which was like canine tumors, so dog tumors. Yeah.
That's a tough question. Perhaps we did, I don't know, perhaps we did kind of science. we didn't, I don't know, we didn't over advertise what we did. We are, well, we know what we did. We know what our algorithm is able to do. We did kind of a clean discussion. We highlighted our limitations. We highlighted everything that we did. We didn't want to over advertise things. Yeah, I think it was a clean paper, I guess.
Well said. Yeah. No, I think like what Jonathan has pointed out is mostly what I'm also thinking. So in general, we had I think it was like just a rock solid science paper, right? So it was targeted towards insights, not towards methods. So we wanted to find out stuff. We wanted to see if that's possible, how well we do against the human baseline. And it was really just the science focus of the paper, I think, that kind of, was what the reviewers agreed was actually, which was also in the reviews actually, right? Yeah. So they were really happy that it wasn't yet another new method that just does yet another 1% increase in something, which is, I think, what many people are a little bit tired of in some regions now.
Yes, I think so. I don't think that this will be our last paper on Agnos.
No.
So yeah, perhaps we will get our hands on a lot more data, and I think we will continue working there.
Yeah.
Interesting things would be to see if we know that there is some, or we know that that it's highly correlated to outcome, the Agnos score and everything. That would be something where we could focus our interests in. During my talk at the BBM, I talked about set stacks because we found out that focus is really of interest in Agnos. It's not, that was a limitation of what we did with our human raters, because the Agnos are so small and they are on different focal planes that with only one focal plane available, like what we have on digital slides, it's not too easy to annotate them, and also not too easy to detect them. And so perhaps something, or to do something with set stacks where we have different focal planes, would be really of interest. So yeah, I think there's a lot of work to do.
So I mean, we can already reveal that we got a pretty nice package in the mail from our partners from Berlin, who sent us a couple of slides, because we also have microscopes here, of course, where we were then able to focus through everything. So we are lucky enough that we don't only have like the compute hardware, but also like the microscopes and stuff. And the beauty of this project is that, so this was also a collaboration with Matti Kupel of Michigan State University, and he's apparently sitting on a big pile of cases that he could make available to us, if I understand him correctly. So this is always, of course, great, because then, I mean, all of our research would be supported by so much data. And this is, of course, then a whole another level of hypothesis-driven research that we can do with this.
Well, the BBM is kind of a very small German conference. So for us, it's a very nice community meeting, I guess. There are all the people from Germany or from the neighboring countries who are working in the field of medical imaging. And well, you know each other and see what all the other people did the last year. That's really kind of a really nice community event, I guess.
We also do bad science. No, just joking. We are really interested in the whole topic around like tumor biology, of course, understanding tumor biology, using methods of deep learning, of course, using methods of data science, but not with a fetish towards that, right? So this is for us a tool that we want to use in order to ask questions to the data, to the tissue, for example, and we have like a couple of more things coming in the pipeline that I cannot yet talk about, but I'm pretty sure it will be around the topic of tumor behavior and so on. So there's quite some interesting things happening at the moment. So hope that everyone keeps our website deepmicroscopy.org in mind. So just look there. We have like every week or so, we have like a blog post saying what we're doing. That would be like, yeah.